Welcome back to A350 Checkride, and thank you for joining me. Today, we're taking a closer look at the Airbus A350 air conditioning system. At first glance, it's one of those systems that can feel dense and layered, but once you step back and look at the architecture, the logic behind it becomes very clear and very deliberate. From the outset, Airbus separates the system into two distinct cooling concepts operating in parallel. The primary air conditioning system is supplied by engine bleed air and is responsible for cockpit and cabin ventilation, temperature control, and continuous fresh air supply. Alongside it is a completely separate, electrically powered supplemental cooling system dedicated exclusively to the galleys and based on liquid cooling technology. That separation is fundamental. Bleed air is used to manage people. Electrical cooling is used to manage equipment, different energy sources, different priorities, but the same objective: reliability and efficiency. From a flight crew perspective, the most important point is that the system is fully automatic. In normal operation, there is no requirement for pilots to actively manage temperatures or airflow. The air conditioning system is controlled by dedicated pack controllers, with one controller assigned to each pack. Each controller is dual channel, meaning it contains two independent control paths, either of which can operate the pack on its own. If one channel fails, the pack continues operating normally. If the entire controller fails, only that specific pack is lost. With two independent packs installed, redundancy is inherent in the design. At its core, the system does exactly what the documentation states in very simple terms. The packs provide cold air by cooling hot bleed air. Hot bleed air enters each pack through the pack valve and passes first through a primary heat exchanger, where it is cooled using outside air. From there, the air flows through an air cycle machine, where further cooling is achieved through compression and expansion. The cooling air itself is drawn continuously from outside the aircraft through ram air inlet doors during normal operation. This airflow absorbs heat from the bleed air and is then exhausted overboard. While the concept is similar to emergency ram air, the hardware and purpose are entirely different and optimized for continuous operation. Once the air has been conditioned by the pack, its outlet temperature is regulated by the temperature control valve. This valve fine-tunes the pack outlet by adjusting internal airflow, while the pack controller simultaneously modulates ram air door positions to maintain the target temperature. From there, the conditioned air moves downstream into the cabin distribution system. Before reaching the cabin, pack air is mixed with recycled cabin air through a series of premixers and a central mixer unit. This blended airflow forms the baseline supply for the aircraft. Final temperature control is then achieved at the zone level using the trim air system. Hot bleed air is added to individual zones through trim air valves supplied by hot air manifolds. A trim air shutoff valve, which is normally closed, provides system protection and automatically opens in response to specific failure conditions. One particularly elegant feature of the A350 air conditioning system is how temperature demand is prioritized. The pack outlet temperature is always set to satisfy the coldest temperature demand of any zone. That coldest zone becomes the baseline, and all other zones are then adjusted upward by adding trim air as required. This logic minimizes the use of hot bleed air, reducing energy demand while still allowing precise zone-level temperature control. Zones with the lowest heating requirement receive no trim air at all. Airflow through the cabin is normally controlled automatically based on aircraft altitude and passenger load. The crew does have the ability to manually select flow modes, including normal, manual, low, or high flow. Low flow reduces airflow to approximately 80%, while high flow increases it to roughly 120% or more. However, system logic always takes priority. If only one pack is operating, or if bleed air is being supplied by the APU, the system automatically commands high flow regardless of the crew's selection. This ensures adequate ventilation and temperature control under degraded conditions. In the event of a dual pack failure, emergency ventilation remains available. Outside air can be introduced into the cabin through an emergency ram air inlet, selected manually by the crew. This inlet will only open if the pressure differential is below approximately 2 psi. A downstream check valve prevents airflow if pressure conditions are unsafe, ensuring structural protection is never compromised. Cargo compartments are managed with a slightly different philosophy. The bulk cargo compartment receives heating only and has no cooling capability. The forward cargo compartment, on the other hand, benefits from full temperature regulation using the same mixer and trim air architecture as the passenger cabin. This distinction is explicit and operationally significant. Completely independent of all bleed air functionality is the supplemental electric cooling system dedicated to the galleys. This system is entirely electrical and consists of two cooling units, a coolant distribution module, and a refrigeration unit that actively chills the coolant. If one cooling unit fails, cooling performance is reduced but not lost entirely. As long as electrical power is available, galley cooling remains functional and independent of engine bleed air. When you step back and look at the system as a whole, the design philosophy becomes very clear. Redundancy is built into every layer. Energy sources are separated by function, safety margins are hard-coded into the system logic, and pilot workload is minimized through automation without removing authority. Two design choices stand out in particular. First, the deliberate decision to anchor pack temperature to the coldest zone, minimizing unnecessary heating demand, and second, the explicit limitation of bulk cargo to heating only, a simple but important operational detail. That brings us to the end of today's discussion on the air conditioning system. Thanks for listening. And in the next episode, we'll take a closer look at the Airbus A350 ventilation system. Until then, fly safe.